Gradient descent. This tool will help you visualize and understand the gradient descent algorithm. Gradient descent is like a treasure hunter trying to find the bottom of a valley. Imagine you're blindfolded and placed on a mountain. Your goal is to reach the lowest point. You can only feel the slope using your hands or feet. To start, you take a small step downhill in the steepest direction you can sense. You can repeat this process, taking small steps and adjusting your direction each time. Gradually, you'll find yourself descending closer to the valley floor. The gradient descent algorithm in machine learning works the same way. The valley represents the error or loss in our model's predictions. The goal is to minimize this error. The slope at each point corresponds to the gradient, which tells us the direction of the steepest descent. This chart illustrates the machine learning process akin to treasure hunting, where each learning step or epoch aims to minimize the loss function value. It visually represents the journey of gradient descent, with the x-axis denoting the number of epochs and the y-axis indicating the value of the loss function. As the epochs progress, one can observe an exponential decline in the loss function, showcasing the algorithm's effectiveness in optimizing and reducing errors over time. This tool will help you understand how the gradient descent algorithm works. Let's explore it. Our example is a simple two-dimensional xy data, and we want to fit a straight line y hat equal to ax plus b. Here we choose the initial values of the parameters a and b along with the learning rate. This learning rate in gradient descent is like the size of the steps we take as we descend the mountain. Too large of a step might overshoot the valley, and too small of a step might take too long or get stuck in a small dip. Let's leave the default values for a, b, and alpha for now. Next, we initialize the algorithm by pressing the Initialize button. To make it easier to understand, we have created this table where several data variables are used to calculate the new value of parameters a and b shown here. These variables include x, y, y hat, which is the predicted y value, the error or delta between the two, double the error, which is used in the gradient descent formula, and the square of the error to calculate the loss. We compute these variables for each row of x and y data. Here we show the epoch number, which represents a complete iteration over the entire training data set, where the algorithm updates the model parameters a and b. The loss is the average of the error squared. So basically, it's the average of this last column here. Next, by calculating these intermediate variable values, we compute the new values of parameters a and b. These are the formulas used to calculate these variables and parameters. In these equations, alpha is the learning rate, which can be selected using this drop-down list. The equations use simple chaining rules of partial differential equations and their evaluation. There are many articles and forums where you can find these equations and the math behind them. On the right side, we show several plots, including xy plot, loss function plot, and the plots for the parameters a and b versus time. Now, if we want to iterate through the gradient descent function, we need to keep pressing the next button. And as a result, the new values of parameters a and b will be calculated along with updating the plot on the right side. Let's try it. Note the value of the loss function. We click the next button, and as we can see, the loss decreases at each epoch, and the regression line converges, trying to fit the input data more closely. Let's continue until we notice that there is no further reduction in the loss value. There we go. Now, if we're satisfied with this loss or error value, then the final values of a and b are these values. that represent the regression line on the right-hand side. Now let's see what the loss function graph looks like using this drop down here. As you can see, it begins by falling rapidly and then converges to its minimum value. Similarly, we can see the history of the parameters A and B. Let's select the XY plot again. The tool allows us to experiment with arbitrary input data and different initial values A, B, and alpha. Let's try another experiment. So we can go ahead and set the value of A to 0, B to 0 as well, and alpha to 0.05. Now we press the Initialize button, and all the variables, tables, and graphs are initialized and updated accordingly. Now, after a few iterations of epochs, notice that the loss and the regression line become static and stop adjusting. This shows that the gradient descent algorithm is very sensitive to the initial values of the parameters and the learning rate. In some cases, the algorithm can actually diverge instead of converging. For this reason, AI and ML researchers have developed strategies to initialize the model parameters. This covers how to use the tool to learn and experiment with the gradient descent algorithm. Please feel free to play with it by using your own XY data and choosing different values for A, B, and alpha.